This podcast is supported by Siemens, your partner for industrial-grade AI.
Hello everybody and welcome to a new episode of our Industrial AI podcast. My name is Robert Weber and I have invited two guests today. The first guest is Christian Wagner from Vogt Ultrasonic and Jan Kutnik from Evoptima. Hello Christian.
Hey Robert, good morning.
Hello Jan, welcome to the podcast.
Good morning.
You two have developed an AI-based product together. It's about non-destructive material testing in ultrasonic at welding spot and a robotics application too. And we already had an episode on this topic with Audi a few weeks ago. And then you got in touch and said, there's more to it than that. And I'm really excited to hear more. But before we get started, please introduce yourself briefly to our listeners. Christian, please start.
Yeah, hello, good morning. I'm Christian. Right now I'm managing Vogt Ultrasonics in Hanover, one of the leading NDT suppliers in the world for spot weld inspection. And we do a lot of things with AI because ultrasonic in relation to inspection, quality inspection, has to cover a lot of data. And that's an ideal base for the usage of AI, of course.
Thanks a lot. We will hear more today. And Jan, please introduce yourself briefly to the listeners.
Okay, my name is Jan Kutnik. I hold a PhD from the Czech Technical University. I'm Czech. Then I checked out in 2009, went to ITSIA, the Swiss AI lab, where I worked with Jürgen Schmidhuber. And now I have my own company, Evoptima, which is supplying AI for any kind of industries.
Okay, thanks, Jan. You have already been our guest, I think, 2 times in the podcast. So it's the third time you are part of this, right?
Exactly.
Perfect. Christian, let's start. What was the problem your customers were facing? How did you come up with the idea of using AI to solve it?
Yeah, honestly speaking, the original problem was that our current software and the devices was not as good as I would like to have it from a customer perspective.
Okay. So it's a quality topic at your side.
Due to that, last year we decided to do the software completely new. And since we work with so much data, because when we do a spot weld inspection, for every spot we do 729 pictures because we are using phased array technology on the ultrasonic side. And that occurs that we have so much data. And with so much data, we can do something with AI, I thought. And that was the reason when I got in contact with Jan.
Okay. Can you explain a little bit for our listeners the process? What do you do and why is it so crucial for its automotive industry, right?
Yes, mainly you do spot weld inspection in the automotive industry. There are some other applications as well, but I would say 90% plus is in the automotive business. And as you know, with a full car body, with a complete car, we talk about 4,000 to 5,000 spots roughly. And we have different type of spots. There are also, let's say, the US guys call it safety spots. Yeah, that means the spots where maybe the seats are fixed in the car body or where the belts are fixed in the car body. And so then we talk about security issues as well. So the inspection of the spot welds in general is very important. And the ultrasonic technology is one possibility to inspect these kind of things. And that's where we are.
Okay. And why was the existing solution no longer sufficient for this approach?
I mean, from the technical side with the phased array technology, and so we are quite good. We are quite well. What I didn't like was our software, the UX, the UI, and that led us to the point that we have to decide whether we will improve the existing software product, let's say, or to do something new. And my clear idea was to do something new, which is much more user orientated, but also from the technology background, which covers the future technologies, and that's for sure AI.
And then you found Jan, and I heard some rumors that the podcast played a certain role in that, right?
Yes, of course. I mean, that was one of the points we started, and I got in touch with you, as you remember. So I think you need the right people to find good solutions, and I think Jan is a perfect fit.
Perfect. So let's talk a little bit about the AI approach. Christian already mentioned he has tons of data. So Jan, you must be very happy when you start a project like this with tons of data. Can you explain us a little bit the task and how you got started?
Exactly. So we were approached by Vogt Ultrasonics on like a suite of tasks, right? And initially it was about that the company needs to improve their software, and there are various different tasks that we can deal with. But we did like a very, let's say, quick experiment with the snippet of like a very small subset of the data set Vogt has. And there was always a promise that we can get much more data, which is actually true. And that's what we are doing right now. But we ended up experimenting with this huge data set, basically trying to improve the accuracy of the ultrasonic prediction. Because, as Christian mentioned, there are these sets of one measurement, and each of the set contains 722 at most signals of ultrasonic echoes, which is, you can imagine, that's like an audio. So you have 722 audio samples. And then the classic software is to take each of these individual curves separately and do some analysis with like engineered approach. Let's say we do some filtering, we detect this maximum, we detect the period and then the number of peaks and so on. And for each of these curves, you assign it a label, whether it's okay or not okay. And then you get sort of like a picture.
So only two states, okay and not okay.
There are more, but like I'm trying to explain very simple. And then from this, you get sort of like a map, 27 times 27, which shows you an image, like a projection of the actual spot weld in the data. And there you measure the diameter of the so-called nugget, which is the piece of metal which gets there by welding, which is created by welding. And that's what's important for the car manufacturers, because if this spot is too small, the weld is bad, and if it's large, it's okay. And it has also other properties like the thickness of the material and so on, etc., etc. But in the end, this is the value that everybody's interested, right? You put the probe to the material and you want to know the diameter of the nugget. And so we circumvent all that with AI, and we basically learn to predict these values from the raw data that the ultrasonic probe supplies. There's one important thing is the ultrasonic customers, they always, for some spots, not for all of them, right? But for some spots, they tear them up, they destroy the weld, and then they measure the actual size of the nugget, which is for us the ground truth, and we use that from learning. So we go directly from those ultrasonic signals to the nugget size, and we basically avoid all that synthetic engineered processing in between.
Mm-hmm. So it was a vision approach, right?
Well, it's more sequential data analysis.
Okay, so it's a time series topic.
It's time series, yes, exactly. It's time series, but it's multiple of them. Like 722 people talking to you at the same time.
Okay, let's come back to data quality. Is there a difference when it comes to data quality when it comes to different automotive companies?
Yes. I mean, you can see.
Of course.
Yes, of course.
Yes, I mean, of course, the difference between the different automotive makers is clearly there because they have different production strategies, different equipment on the welding side, and also how to judge about the quality of a spot weld. Maybe it's also different. And we have to adapt because we are the last gate at the process. So we have to adapt to the needs of our customers, and we will, of course, or probably in the future, we will also offer to our software a kind of extra service, like we will train the models to your specific needs. Yeah, because we know that it is necessary, and we see that already.
From an AI perspective, Jan, what is so difficult with the different data approaches?
What is the difficulty there in this specific case? Well, there are two things. One of them is research, right? Because it seems like not really anyone has coped with that before. And we don't know how far we can get. So that's interesting and stressful at the same time, right? Because you want to deliver it to the product, and we at this point we are able to reduce the error in the nugget size prediction by, let's say, 30% in average, but we don't know how far we can go, right? Maybe it could be 50% eventually. So that's hard to predict. And then the other thing is that there are always some little devils hidden in the details. So what we are trying to do is basically to cover the distribution of all possible measurements such that our algorithm is robust enough and can be used in all the cases. Because as Christian mentioned, there might be like quality discrepancy between the car makers, and by far largest discrepancies between how the workers actually use the probe and how good data they get, because from some it's harder, from some it's easier, and we need to be prepared also for those bad, let's say, coupling of the probe with the material, such that even if we get like really bad data, we can actually estimate the nugget size from it, and that's the real challenge.
You mentioned a robust model, a robust AI approach. What means robust in this project?
It means that if the nugget size in the data is large, we provide large value. If it's small, we provide small value, right? Such that we catch all the welds which are bad, and the solution is stable. So it basically, like, if you give it some sort of crazy data, right, it wouldn't tell you that the nugget is too big, like, I know 1 meter wide, which is nonsense, or negative, right? We can filter out easy, but yeah, things like that, like that, it gives reasonable results for all kinds of data if they contain reasonable material inside.
Before we talk, you mentioned everything will be protected by patents, but can you explain a little bit how the AI model works, what kind of algorithm you use then, and then how do you got it onto the device at the end? Jan.
Okay, so we have explored several, let's say, I think it's like 5, 6 ways of pre-processing the data. We have also explored different architectures, and now it's a mixture of those. So we have done a lot of experiments with like huge sizes of data. There's always something which we can add on top of it, but imagine that you have, let's say, it's a sequential data. So there is like a flavor of LSTM which takes it sequentially, and then there is some, and because it creates these various, let's say, maps out of it, then there are some bits from like computer vision, because now we are looking sort of at images, something what you mentioned in the beginning. So it's a combination of these. So the model is like very problem specific, I would say, but it still retains the property of processing the data in parallel. So that's the main difference, that's the main advantage, that it looks at all the data at once, which makes it more robust to the noise, for example. Like the legacy algorithm, let's say, if you look at it and you have some clear, let's say, nugget image there, it looks like a disk, right? And then if it's really perfectly measured, all the points inside the nugget should be green, but once in a while sometimes there's like a red one, right? It says this signal was bad. But if you actually look at the signal looks like the neighborhood signals. It's not that much of a difference, but the AI takes this into consideration, because since it's processing everything at once, it filters out these outliers, and it says, when the signal is really like close to be good, it says it's good. And that, I think, is the main advantage.
Okay, so it sounds a bit for me, what Christian said, he wants to do some fine tuning with the model. That sounds a little bit that this is a welding spot, let's call it small foundation model, Jan, or am I wrong?
Well, it's more like, it's a really hard task to cover all possible data sets from all possible car manufacturers, right?
But you did it.
We did it, but we still don't know if, let's say, we know that if we train this model, which is exactly the same, but we train it from that very specific distribution of data from one car manufacturer, it could be a big advantage because it adapts to how they measure, right? It adapts to how they weld actually. And it may capture some very specific features which are coming from their data specifically. So although we have like really good model, let's call it foundation model, which would cover everybody, and if you get the device, you should be able to start measuring with your car manufacturer. But there's always the possibility to train specifically to the data which your, car industry or factory produces, and this still scrape off some margin of improvement, which I think is nice.
Is this the path to go, Christian, to build one big model and then fine tune for different approaches in the automotive industry?
To be honest, right now we don't know. We will try it, but let me go one step back if possible, because Jan explained from his point of view, which is more scientific. But what I feel is very important, and maybe this is not only related to our application or to the spot weld inspection, to adapt the AI to the specific situation in the production, because we have a lot of impact from the quality of the welding, maybe the kind of material people or customers are using, then the quality of the inspection. Not to say that someone does it wrong or right, but maybe it's different how to inspect in India or how to inspect in China or how to inspect in Europe. And our job is to cover all these circumstances in the best possible way. And finally, to bring with our AI idea better results. I mean, that's our main priority, to improve the precision of our measurement in total.
Let's talk about precision. How much benefit does a customer has at the end?
I mean, right now we are in a, let's say, in a full R&D mode, yeah, still. But what we found with the specific data we have inspected or we had to train the models, I think right now we can say we are able to improve the precision of the inspection by probably 20, 25, 30% with the AI. And that's a lot. That's really a lot. And this is what we would like to have. And we will use the AI on the user side as well to improve the usability of the software, etc., etc. But the core target was always to get better.
Mm-hmm. Jan, what are the computing requirements of the model? You mentioned it's like a LSTM, so you can run it on the edge or an industrial PC on the shop floor. What is the idea?
Yeah, so that comes, that's the second part of the question you asked before, right?
Exactly.
It runs on the actual phases device, which is like a rugged industrial tablet embedded in like a rugged case with 2 batteries.
So it's a normal Intel whatever chip.
It is Intel, but it's because it has some requirements also from the car manufacturers, and it could be like super powerful, GPU thing, because it's battery powered also. So it runs on a normal PC, but not like the latest greatest, right? It's some device which is like a little weaker than the usual computer. And so this is one requirement for us. And it has to run there, and it has 0 internet connection.
Mm-hmm. And how do you solve this problem?
Well, we optimize the model such that...
How do you optimize a model like this to run on a let's say 10 years old Intel chip?
Something like that. Yeah, we run experiments and try to shrink it until it breaks, and then we optimize the runtime. But all the available runtimes which are there now are like pretty optimized already, right? You don't have to get down to fine-tune your convolution kernels like we used to do 15 years ago. So we use libraries.
Okay. Christian, now you have an AI model, but you already mentioned you're in R&D phase, but now you need to integrate this AI model in the processes. And are you now redefining the process? And is there an automation add-on, or what is the idea now at Vogt?
Yeah, we have a few parts. I mean, when we started the work with Jan, in the same time we decided to make the software completely new from scrap. So we have two teams working on it. Jan is with his team is for the AI side. These are the scientificists, I would say, and then we have a classic software developing team working on the new software, and we combined it in the background. So once we will have the new software, we will implement the AI. As I always said, it will be the core of the new software solution. So that's the idea. And this is then for all kind of applications and devices, because we have the classic handheld unit, as Jan described it before, with the tablet screen, and this is used for manual inspection.
So the guy is going into the car and checking with a camera, right?
Exactly. The guy is going with the unit into the full car body or stands in front of the component, and he inspects the different spots according to a test plan, which is in the automotive industry
very strict.
Yeah, normal. Yeah, or they do it, I would say, when they have a quality issue in the production, then they go with the unit to the production line and inspect directly at the production line and try to figure out what happens there. And we have a unit without the screen, which is called Faces Blue, and this is dedicated to, in general, dedicated to automation with a REST interface, because it has no output screen, so you need a laptop or any other device to see the results. But from the technical side, it's exactly the same as the Neo, and we use the Blue for our now under development new automation solutions, because you have to see a manual inspection workplace. In average, they inspect between, let's say, 600 and 900 spots per day by hand. And that is a classic, sorry to say that's a classic stupid job.
It's a monkey work, right? A bit.
Yeah, it's tough. It's monotone, and there we start with one of our automation solutions. That's with a collaborative robot.
So the camera, is it a camera? It's on the robot.
Yes, the camera. We have a 3D vision, which is mounted on the collaborative robot in front, and which gives us all the informations we need. Where is the piece? Where is the spot? How is the system in relation to the component located, etc., etc. And there we also use AI in the vision software, because the spot can be good or not so good.
But this is a state-of-the-art model, right? So this is not scientific.
No, this is a deep learning model we run with a software which will be provided by the vision.
Exactly, by the company who is providing the camera, right?
So we combine AI with AI. Let's say like that. Yeah. So we have the AI in the vision, and we have the AI in the software of the ultrasonic equipment.
Mm-hmm. How difficult is it to pair, Jan, both AIs?
It's, they are at, let's say, far edges of the device. So first that vision is used to navigate to the actual spot, and then the data is captured, and then our component gets the data and outputs the quality of the weld. So it's connected, technically it's done through some API which is running there, and then in the end our software can be called from anywhere else. So the company which makes the software to user interface for the Faces Neo for the device integrates our solution inside and through the API and through the calls. So it's like a plugin.
And Christian, the cobot is working with the camera and the AI model by Jan. But is he then driving into the car body and checking there? Or can you explain a little bit the use case?
Okay, the original idea is we have a mobile base. On the mobile base is the collaborative robot mounted. You don't have to say cobot anymore. This will change at the beginning of next year. But then, as it always, we visited the first customer, and we had a discussion about the mobile solution. They say that's great, but we want to have it on an AGV. And I said, okay. Then we have the next complexity step we have to move, because we are prototyping and we have a full car body and we would like to have the system to drive on the right back corner and inspect there, and then we have to move it to the right front corner of the car and blah. Okay, so that will be the next step. But in general, yes, the robot is mobile mount, or the whole system is mobile. You can move it from A to B. And since we have this 3D vision, which will help us to orientate either the system and the component versus the system, we will be able to inspect everywhere, and we always know where we are. The only issue you have with the robot, but you have this with all kind of robots, that you will not reach all kind of spots which will be reachable by hand.
Exactly.
So you have some limitations, but that is given by the physical situation, and you have to re-inspect some of the spots by hand always. That's normal.
How much do you have to re-inspect?
I mean, I think with a collaborative robot, we will have some advantage against the industrial robot, because the industrial robot is normally much larger. So we talk about 2.60 meters, 3-meter reach. Yeah. Even when we do not carry high payload, or even when we don't have to move the robot very fast. But we need the pure reach if you would like to inspect the full car body. Yeah, you need this reach to get to reach all the spots. But with a collaborative robot, I think we will have the chance to improve our reachability in terms of what kind of spots we will be able to reach. But I think always between 10, 15, maybe 20% will be not reachable with the robot. So you have to inspect them by hand if you want to inspect them. Yeah.
That's a very, very interesting approach. So, Christian, Vogt is not a global, let's call it, corporation or big company. It's a typical German mid-sized company. And what encouraged you to go down this path with Jan and his team? Because we always talk about the problem that mid-sized companies are too slow to adapt AI. But what encouraged you to go this way?
I mean, all the different facts we had, a lot of data, very fortunate hardware technology with the phased array system. Our history over 40 years in this industry, plus the needs of our customers, because we see that the OEMs are trying to improve quality, and if they try to improve quality, they have to inspect it. So all these different impacts brought us to the point that we said, okay, let's go this step.
So it was more pressure than, oh, let's do another way, or is it a combination of pressure and we want to try out something new?
Both. I would say,
okay,
I'm not a fan of Me Too. So what all others do, yeah, we look at it and we respect it, but you have to find your own way. And for me, it was clear, so much data and such a good hardware technology that maybe that's a call for AI nowadays. Yeah.
Absolutely. So what advice would you give to other companies when they are mid-sized companies?
When it comes to AI, I would say...
Yeah, when it comes to how to start a project like this with Jan. What is crucial in a project like this?
The first thing is you have to find the right people, like we did with Jan, and you have to start talking about the opportunities, and then you have to try often, fail fast. I mean, that's what we are doing. You can ask Jan, how often did we had a call in the night or somewhere? Because
Jan, how often?
I mean, we talk all the time.
Okay.
It's a real huge demand of communication.
Mm-hmm. Jan, it's not about technology. It's about finding the right people to communicate with these people and to build a team out of it. Is it more than this, than a technical approach?
I think it's a big part of it. And then one big thing is courage, and basically to have enough courage and not be afraid of innovating, right? Because this is what forces us to, this is what helps us to survive. And we've seen that through COVID. The COVID was kind of that year or 2 years was a bit scary, because a lot of the companies thought, okay, now we will have to save the cash for wages for our employees. in order to survive. But then the others innovated and they got far. And when the COVID was over, those who saved the wages were out of cash because they didn't innovate in the meantime. So I think it's very important aspect is to have courage to innovate and to try something new and to see how far we can go. And this is what Christian and his team has. So and we like customers like that who are basically not sitting ducks and going forward.
Christian, at the end, let's talk briefly about competition. Where are you stand now when it comes to competitors?
I mean, we have respectable competitors. They have also good systems. But I mean, this industry, this ultrasonic industry, especially when we talk about spot weld inspection, we don't talk about so much suppliers in the world. Maybe we talk about 4 or 5 plus minus. Yeah. So that's a very small niche where we are acting. And I don't know what they are planning with regards to the future, but we have defined our way with the AI and with all the improvements we would like to achieve. And I think it's a good way because we see that from the response of our customers. Yeah, they are all very interested in this AI software, and they are very, very looking forward to it when we bring the first kind of software end of the year.
So what surprised me most in this use case is that you have all these data. How easy is it, or is it to get these data? Because it's automotive IP, or I don't know. How easy is it to collect these kind of data?
Yeah, we need the agreements.
Yeah, sure.
So we do not take any.
So you told them we planned something to do with that.
Yes, we offered them. And the funny thing is we talked with many OEMs and many of the car manufacturers, and not just a few of them, when they heard, oh, they are doing something with can we give you data? Then we said, yes, of course, we need data. And we do not only need the good ones, we also need the bad ones. Yeah. Because that's also very important when you train the model, that you show the model everything. Yeah,
Mm-hmm.
That's the hard part, actually, right? Because some of the car manufacturers make so good cars and their welds are so perfect that basically there is a lack of crappy data, and we need those for learning as well to make the model more robust.
Mm-hmm. So, what did you learn in the project, Jan, at the end?
I would say, like, on that note of we discussed already, the communication is the key, like to be straightforward and upfront on all the issues and everything which comes to your way, like such that basically no hiding, waiting, and this we should have told you that a week ago, that like if you say that's a really bad idea, that shouldn't happen. But in this case it doesn't. So we have like very open communication, and then I'm in touch with some people from Christian team almost on daily basis, and that's one thing which sort of like reinforced my approach. And yeah, I'm thinking like, I mean, in this case, we mostly milk what we have learned in the past failures. So
Thanks a lot, guys. I'm really proud because we made the connection via the podcast between you guys, and now there's this great outcome. And yeah, we are a bit proud. Thanks a lot, Jan. It was a pleasure again to talk to you.
Yeah, I appreciate. Yeah, thank you.
And Christian, thanks a lot. It was a pleasure.
Welcome. Thanks a lot.
Thank you.